In question 6a, we're asked to differentiate the function from first principles. As in previous questions, I've set up first a generic coordinate with x coordinate x, therefore giving us a y coordinate of 3x squared minus 4x plus 7. Then our tiny distance across the x-axis, delta x, generating obviously our x plus delta x coordinate, and then substituting x plus delta x into the y function. Once we've got this, we now can move forward and just work out the gradient of this curve as if it was in fact just a right angled triangle due to the small distances involved by looking at the change in y over the change in x, in this case delta y over delta x. So the change in y coordinates would be 3x plus delta x squared minus 4x plus delta x plus 7 minus 3x squared minus 4x plus 7 all over our small movement in the x-axis of delta x. Next stage obviously is to expand our brackets, giving us delta y over delta x is equal to 3x squared plus 6x delta x plus 3 delta x squared minus 4x minus 4 delta x plus 7 minus 3x squared plus 4x minus 7 all over delta x. Again, the numerator always looks quite bad at this stage, but then immediately you can see that quite a lot cancels. 3x squared minus 3x squared minus 4x plus 4x plus 7 minus 7, leaving us with 6x delta x plus 3 delta x squared minus 4 delta x all over delta x. At this point you'll see that delta x is apparent in all the terms of this expression, so we can divide through by delta x, giving us 6x plus 3 delta x minus 4. The next stage to realise is this delta x was just a generic distance across the x-axis, so we could vary that to the point where delta x approaches 0. And what happens there, our little function delta y by delta x will become 6x minus 4 because delta x actually becomes insignificant. Therefore, differentiating our function from first principles gives us dy by dx is equal to 6x minus 4.